SciByte is produced by JupiterBroadcasting.com, independent entertainment that's on demand. Check us out. Hi everyone, you're listening to SciByte, Jupiter Broadcasting's weekly science podcast. We recorded this one live on April 24th, 2012, and released it for download on April 25th, 2012. My name is Chris, and joining us like every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Happy science to you.
Happy science.
What do we have coming up on the 43rd episode of SciByte today?
Today, we're going to look at Aurora on Uranus, Martian dust devils, counting penguins, Apollo 8 images, the high-altitude jet stream, latest on the shuttles, and as always, take a peek back into history and up in the sky this week.
That's right. You can have a little fun while you're getting your information this week. We got a great show lined up. I'm honestly looking forward to trying to get through the entire episode without giggling every time you say Uranus.
It is the planet.
Yeah.
Yeah.
No,
yes.
I'm mature. I got this, Heather. I got this in the bag. Are you kidding me?
Uh-huh.
All right. Well, why don't we jump into our first news story? What is the first news story today?
Okay, today we're going to take a look at the planet Uranus, also known as the planet between Saturn and Neptune.
Right.
So this planet has a really bizarre tilt. It's actually like a little over 90-degree tilt to the rest of the planets. You know, everything else is kind of rotating vertically. Uranus does this weird, totally sideways rotation. And so the magnetic axis is 60 degrees off that.
Huh.
So it's very, tilted in all sorts of crazy directions. And the magnetic field is totally off from the planet in way more ways than we think. And so we know that, auroras when the magnetic field lines of the Earth converge at the planet's poles, and you get charged solar particles coming in, and it makes the green and red sheets that we all see.
Right.
Well, we can see in pictures at least, if none of us are not south enough or north enough for that. But now, an international team of astronomers have actually used the Hubble to capture the first aurora seen on Uranus from Earth.
Awesome.
They've originally have seen it only one other time. Jupiter, Voyager, when it did its flyby in 1986.
Yeah.
It actually saw some. But there, the probe, it had a lot better view. It was a lot closer. So they were able to see the back side of the planet. And so they could see it better. It lasted pretty long. It covered a large area of the planet. So they were able to see all that from the unlit side of Uranus.
Huh.
And so they've tried before to kind of detect this phenomena in 98, in 2005. So these new observations, they pretty much think it only lasts for a couple of minutes.
So when I'm looking at this picture, is that this little like almost cloud-looking dot on the surface that's kind of protruding?
The little white dot, like you had it in paint and you accidentally clicked
right
in the middle of the planet. Like, click white. Oh, oops. I didn't mean to do that. Oh, wait, we're going to call that Aurora. No, but it is Aurora. So, it only lasts a few minutes. So it's kind of a trick to be able to...
It must be substantially weaker than ours, right? because it's so much further away. Wouldn't it? What doesn't...
Yeah. Yeah, and luckily, it is farther away. So they're able to sort of time it so that their turn on the Hubble was when a storm was going to hit. We get those coronal mass ejections.
Yeah.
And with Uranus is far enough away that you get a 3-month head start. So you see it blasting off. You can tell that it's going to be in the right position. Yeah. And so you have 3 months to prep.
I see.
So they're able to kind of catch their window on the Hubble, be able to make these observations. And it was November of last year in 2011 that they were able to catch those. They only last a couple of minutes, so it's very tricky to actually catch those. So they have to do a lot of observations as much as they can and kind of weed through everything until they see that. Now they're hoping that these new observations are going to help us understand the magnetic field of Uranus, which is so off base from everyone else. It might give us kind of insights into the crazy things that
because there's been speculation that maybe it got knocked off its core, and maybe something like that could happen to Earth. There's been all kinds of if we could understand if something caused this, then maybe we could figure out if something could cause that here. Yeah,
and even just the magnetic field itself. If you can understand, I mean, looking at with our increasing technological society, we're worried about these, magnetic storms and solar that kind of stuff, disrupting satellites and radio. And diverting planes, which we've seen all of these kind of things happen before. And in history, there have been much larger storms that we've seen. So if we kind of study the really strange, and including ours, it might give us a better idea of how to predict these things, what's going on, exactly kind of more information about it in general. And, checking out the planet as well. But it might be some information that we can transfer to here on Earth.
Pretty interesting. And it makes sense because all these things are made from the same stuff we are, and they live in the same backyard. So just
it's gas planet, it's way out there.
Yeah.
But it's it's something interesting that we're kind of looking at.
But when I say it's all made of the same stuff, I don't mean it's a gas planet versus a rock planet. I mean it's
same basic elements.
Yeah, exactly. And it's sort of
same periodic table.
There's things that can happen in those environments that we can then apply back here. So I'm always for it.
Yeah.
Huh. Well, and it also is kind of an interesting deal because I never really thought about a planet that far out would have the auroras on it like we do here. Of course, ours are probably much cooler looking.
Well, we get a slightly better view of it because it's a little bit closer.
Much more intense, huh?
Yeah. But any planet that has the magnetic fields would get that, would have, aurora on that planet. And so it's just about observing that and finding the right time because it's, the solar mass, the coronal mass ejections and things are the high energy particles are still going out. They're hitting all the planets. I mean, it's, spreading out or, getting wider, but something's still going to hit those planets. It might not be as the same as here on Earth or what have you, but it's kind of interesting that, like you said, that they do actually occur out there because you might not really think that the same thing happens.
Yeah, or that I guess that the ejections from the sun travel that far, but of course they would. Yeah. No reason they wouldn't. So makes you wonder if you could somehow harness that. Let's we'll build a solar sail and hitch a ride to one of those bursts to Uranus.
There have been satellite probe ideas that say go on a solar sail. That they've kind of planned out a project that could use that kind of a thing. It's a little bit slower than other modes of transportation, but
yeah. Unless it's built by Bajorans, then all of a sudden it has the ability to go to warp speed. So
that's what I was thinking too. Except then you have to wait for opposing governments to declassify said information. It's all very complicated.
Right. Of course, but then they would throw a fireworks party for you at the end. Yeah. So any other thoughts on that story?
No, I think that's about it.
Okay, good. Well then. That tone reminds us that SciByte is sponsored by the audience, and we have a couple of great ways you can do that, including a brand new affiliate over at jupiterbroadcasting.com. If you scroll down to the bottom of the site, you know about the affiliate links down there because I talk about them all the time. Mm-hmm. And we just added a brand new one. I'm pretty excited. Gamefly. And Gamefly is not one that's for everybody. But I remember back when we were doing Lotso, I was going through video games like crazy, and Gamefly just made a lot of sense for me.
Yeah.
Because for one fee, I could just get a bunch of games and send them back and review them. Now, I don't know how that situation applies to everybody, but if you've been out there and you've been thinking about Gamefly and you want to grab it, please do use our affiliate link at the bottom of jupiterbroadcasting.com. They have a couple of different options. Either you can get 2 games at a time or 1 game at a time. The prices are higher than Netflix because I guess the video games cost more and things like that. And then they also give you good deals if you want to buy one of those rental games. So Gamefly, cool thing to check out. And if you do want to grab a Gamefly account, use our affiliate code at the bottom of use our affiliate link at the bottom of the site, and Jupiter Broadcasting gets a little bit of credit for that Gamefly purchase of yours. So thank you everybody who does that. And that's all. I just thought it was really cool that we had a new affiliate. So everybody go check them out if you're interested. All right, Heather. Then that means it must be time for the SciByte News Bite. All right, Heather, what is our story, the top story in the News Bite?
We've seen it before, and we've got it again. Martian dust devils.
Right on. The Martian party continues.
Yes. So, tornado, dust devil, very different things. Dust devils come on a clear day, ground heated by the sun, warm air, rises and cool air above it, and it's just the right conditions so that they rotate. And the Mars Reconnaissance Orbiter has been examining Mars, 6 science instruments since 2006. And we've had all the rovers, most of the orbiters, the rovers, the landers, they've all captured dust devils in action.
Right.
Some people maybe remember on one of the rovers, they saw some of them, going across the field, and then suddenly their solar panels were nice and cleaned.
Yeah.
And probably figured that a dust devil probably rolled over it.
Right.
But on February 16th, there was a dust devil on Mars that was more than half a mile high and about 90 feet in radius.
Ooh.
So it was fairly big. So that was kind of crazy. But on the March 14th, they actually saw one that was 12 miles high and it was about 230 feet in radius.
12 miles.
Yeah. So it actually went into a much higher part of the atmosphere than they sort of thought it would. So it was very interesting because, some of it is the mass of a dust devil is less than 1% than it would be here on Earth.
Oh, okay.
Because of, the light dust and stuff like that. So it can go a lot higher. As they're, any of these they're able to, any of these they're able to kind of see the tracks of where this has been. And sometimes they'll see other tracks in the area where they're kind of able to see where others were happening. Now, you might think with such a big thing, you wouldn't really want to, hang out where that is, but it's not going to knock you over.
Oh, really? They're not that strong?
No, it's the density of the Martian atmosphere is much lower than here on Earth.
Right.
So you'll get blasted by sand and dust.
Right.
But it's not going to knock you over. Now, you may kind of crunch down because you don't want to get hit by all that dust.
It's getting in my eyes, Heather. Come on, that's horrible. Yeah.
Yeah, that doesn't sound good.
Okay.
But yeah, so these orbiters can spy things as small as a desk. So you can pretty much get any of these small ones. It's just all about the right timing.
Really, as small as a desk, huh?
Yeah, it's all about the right timing. You can kind of check one of these in action as you're going. They've actually made a couple of videos. They can check just from one image. They can kind of interpolate the 3D image of it. They use the shadow on the planet and how it looks from above to kind of guess the shape of it. And as it's going along the surface of the Earth of Mars. So they can make all these videos of how it looks and 3D images of here's a runaround of how it looks. And
what I like about it is even though it's not life, it's a form of activity on Mars that we can observe. And that's really cool.
Yeah, there is definitely atmospheric activity. You can see, the rover's tracks, and as time, there is wind, there's dust storms, those kind of disappear and they start going away. I've actually seen some spacecraft that we know where they are, we know where they landed, and over the years it kind of gets, here it is. Oh, kind of hard to see it. Oh, not there anymore. So probably completely covered,
really?
In red, dust from the planet. So it's kind of camouflaging itself.
Well, no wonder we can't see all the forms of previous life on the planet.
Yeah, they're hiding under the dust. They've got little blankets covered in dust.
Everything covered up. All of their old pyramids, all of their old cities. I'm sure whatever they had. I don't know. Maybe they had.
Of course.
Yeah, of course, right? But the people that lived on Mars.
Yeah.
Let's just start that rumor. Let's be the show where that is like a thing, and we just totally talk like it's a thing.
You heard it here on SciByte first. Martians hide under blankets of sand.
Science fail, Heather. Science fail.
Yeah. Yeah, definite science fail.
But it'd be fun. It would be fun.
Yeah.
All right. Well, I'll stop dreaming about going to Mars. Any other thoughts on that story?
I'm not stopping a dream of going to Mars, but I will make sure to have a dust mask.
There you go. All right. Well, why don't we talk about studying high altitude jet streams? And while I have an idea of what I think that means, I think you're here to set me straight, aren't you?
Yes. We're not talking about the kind of jet streams you see on the weather report at the 9 o'clock news hour. They show the jet stream, dipping here and rising there, and that's why you have really cold weather, or why it gets
yeah.
That's
right. Yep. Of course, yep. The cold front and the jet. Yeah.
Yep. Now this is actually much higher. The upper jet stream has winds about 200 to 300 miles an hour. It's got a lot of electrical turbulence that can actually affect satellites and radio transmissions. So that we haven't really had a lot of information about this, but the NASA had 5 different rockets, so they were going to launch 5 minutes apart.
Mm-hmm.
So it's like one after another. And there was a couple of delays. I was watching, I kind of mounted it on my Twitter, and somebody responded saying, why does it keep getting delayed? It was because it had to have absolutely very clear weather for a distance along the range, because the idea was that they would launch up, release this chemical tracer, and then they would observe what was going on with those tracers. How are they distributed? How is the wind blowing it?
Kind of like when you put dye in water and then and watch the dye move around, and you can kind of see how it circulates through the water and where the different yeah
if you create a little river, you can drop the color blue and watch how it goes everywhere.
Everybody does that, like at the science fair or something like that.
Yeah. So they did have one of these with more data. They had temperature and pressure data, but the hope is to be able to get more information about this. It'll kind of give us another layer of understanding about what the atmosphere of the Earth is doing. It's kind of that big question: where does the atmosphere end? And just kind of dissipates and dissipates and dissipates more and more. But this is kind of on the outer layers of what's kind of going on. It's not the most extreme, but it's up there.
Huh.
And because it can have all this electrical turbulence I was mentioning earlier, we really need to kind of keep a track of it and have a better understanding of it, so that we can kind of predict possibly about how it might affect, satellites or radio or anything in that general area that it could be there.
Right. So they were able to get some good images?
Yeah, they were able to get some good images. They can see, there's some really iconic ones of the rockets going up, but there is some, essentially look like little wispy clouds.
Yeah.
But that is, if they released it, and that's watching it, how it's being distributed.
Ah. It's interesting. It's kind of getting, oh wow, yeah. Well, you kind of see this too sometimes with trails behind jets and stuff.
Yeah, it's as the winds buffet it around, kind of the same idea. We're just releasing it at a much higher altitude than most of those go.
Some of these look like ghosts or some sort of space creature. I bet you could freak some people. Wow, yeah, like this one I'm looking at right now is like a bunch of these things hovering over the city. If I was a pedestrian, I might be freaking out when I saw that.
Like, oh, yep, here comes our alien overlords.
Those look like giant space creatures.
Well, they've got all this data, and NASA will release it after a period of time. They're kind of holding the data internally while they have a chance to review it, kind of get their initial findings on it. Then they will release all the raw data for everyone to kind of look at.
Okay. Huh. Well, you never know what NASA's working on, do you?
No, it's, some of these things, this one kind of popped up on me as I was looking at it, and I was kind of excited. And, it did get delayed a couple times because, they were launching them further and further, down and away. That's why you see them all in a line. So it had to be clear for all these hundreds of miles. They could be seen, from all sorts of different places along the eastern coast of the U.S.
Right.
So that's partly why they had to delay it and wait for the perfect time.
Right. That way you get the pretty pictures.
On all the data.
For the studying. Right. No, I'm just saying.
Well, yeah.
Well, you know what that makes me think? It's time for a spacecraft update. Or 2-byte news. 2-byte news.
2-byte news.
2-byte news. Although we will have a spacecraft update coming up a little bit later in the show.
We will.
All right, what is in the 2Byte news this week, Heather?
All right. Counting penguins. We can do it by, taking a snapshot. Poor little frozen photographer takes a snapshot and they can mark off the photo and kind of count them one at a time, making sure they don't double count anybody.
Right.
Now, it is kind of hard in the far remote places, especially the Antarctic, to get there,
It's
be able
cold.
to. Yeah, it is a little cold.
It's a lot of work for some pictures of some birds, just to put it bluntly.
Yeah, for some non-flying birds. But there is a new technique that they're using to actually use satellite imagery to count penguins.
Of course.
Yes. Well, you can take a picture down. If you have the fine enough resolution, then you can say 1 pixel equals 1 penguin.
Plus,
and so then go.
This is a great way to develop human tracking technology as well. I'm just saying that
How
seems
many
like
humans in the crowd?
right. I mean, or yeah, exactly. Interesting enough. I mean, how do they? Because from that far up, the penguins must seem like they all look alike. Not to be a penguin racist, but wouldn't they all just kind of look alike?
Well, we're just counting numbers. We're not, saying any more data about them.
Okay.
All the
So they take a still.
the lake penguins and the guy penguins and the little penguins, and there's not really any of that. It's
Gotcha.
just penguin.
So they take a still and they count them.
Yeah, penguin, no penguin, penguin.
Right.
So they can go do that. Now, using this, they've actually found twice as many emperor penguins than they even thought existed.
Huh.
The colonies of them, they added 7 new ones. 7 new colonies of these penguins being able to just look from satellite imagery.
Wow. Well, look at them go. Look at those penguins go.
Yep.
Good.
So now we know that there's twice as many as we thought there were before.
Well, that's good. That is good to hear. Now, why don't we talk about a little Apollo 8?
Yes. So back in December of '68, the crew of Apollo 8 were the first humans to take a photograph of the Earth rising over the moon.
Yeah.
Now, a lot of us have seen that very iconic image
Absolutely.
of Earth over moon. There was a black and white version, and then a few minutes later, they were able to take a color picture. Now they've have a video that sort of recreates what they saw. They've gone back and they say, all right, here they were, here's where the moon was, kind of tracking it, and then they kind of interlay the actual images. So they're like, here we're going, computer simulation, and then they'll stop for a moment. Here's the image.
That's awesome.
Then it kind of goes forward a little bit more and like, here's that image.
That is a really neat sort of recreation, and also it gives you sort of an idea of the scale isn't the right word, but how it's so flipped, how small the Earth seems and how large the moon seems in these photos.
Yeah, I mean,
it gives a new scale to these photographs.
Yeah, watching the Earth rise over something. I mean, there's some very iconic moments as we went into space when we could take the first, when the Earth was just a ball in the sky, little blue marble, and then as we went to orbit the moon, how it was rising above, it was rising over the horizon of the moon.
Mm-hmm.
There's all these kind of iconic moments of we are a little marble in the world, in the universe.
Right. Speaking of things we fly by, we have an asteroid update too, don't we?
Yes. There are some images from one of the ESA, the European Space Agency's robotic Rosetta spacecraft mission.
Roboto.
Yeah, Roboto. So they're going by this asteroid, and they're kind of looking at it, trying to figure out the origins of it. It has unusual colors on it. So they wanted to go by, take some data, take some images. What they're able to do is, lay all those images on top of each other, in sequential order, and they're kind of able to make a video of that. So as they were able to fly by, you're kind of able to get an idea of.
So this is a composite of a bunch of stills. What I'm looking at.
Yeah,
sort of animated like an old cartoon.
Well, not even animated. I mean, the spacecraft itself was looking at it and then kind of looking at it from the side and looking at it as it passed. So, I mean, it's kind of watching it as it runs back and forth. Like you have the video camera watching your kid, run up and down the track. You face it to the kid, and then when it gets next to you, you're here. And when it goes down the track, you're looking at the back of the kid. So that's pretty much what they were doing here. So they were kind of tracking it with their image.
It kind of looks like a classic Star Trek ship flyby.
Yeah.
In some sense. Although in Star Trek they were moving the camera, not the ship, and in this, because it is that classic, it comes right up to the camera, and then the camera pans along its side as it flies by. I mean, it's beautifully executed.
Yeah, the asteroid is moving, but the satellite, the probe, is moving much faster by it.
Right.
Trying to get some data on that. We're kind of hoping that there'll be a lot of good info that's coming from that.
That's some good coordination. That is some math that those guys are just nailing. Think about that.
Yes.
Yeah, absolutely. All right. Well, now I jumped the gun before, but now that's right. The SciByte computer is telling us it's time for the spacecraft update.
Yes, I didn't want to have a whole bunch of data in this one because it's the Shuttle Shuffle.
The Shuttle Shuffle.
Yes, Discovery has been delivered to the Smithsonian, and the Enterprise was being taken out, and it's sort of on its way to the New York Space Science Museum.
Sort of on its way?
Well, I'm trying to recall what the latest update on it was. There was some weather delays that to make sure, everything was just right from leaving there to getting there, and they'd had enough time to, get it from the runway into the station, into the museum.
It's a nice tribute that it got to fly by some cities, and people got to sort of pay tribute to it as it flew by.
Yeah, as they were delivering the Discovery to the Smithsonian, it made like 4 flybys around Washington, D.C. So able to get a lot of, iconic images of it flying by the various
I just find it
sites.
Horribly sad.
Yeah, that's why I was like, I'm going to put a whole bunch of images in here because I guess it needs to be said, but...
I mean, it's almost like we recognize what an accomplishment and how important it is, and by paying tribute to it, but like we don't have an answer for what we're going to do now.
Yeah, I mean, I'm looking forward to the next stage, and I'm hoping that...
I kind of wish we could have gone to the next stage as we wrapped up the current stage and not have had this sort of in-between
this lull
period.
in between, yeah. But I mean, the Enterprise, when it was in the Smithsonian, and now they're going to have the Discovery, so it's been to space, it was spent the equivalent of pretty much a year in space all over various times. It was the shuttle that brought us back from after each, after the Challenger incident, after the Columbia. So it kind of was the first shuttle to come back off of both of those. So it has a bit of historical value. Various specific people were on hand to do the handover, when it left Florida, as it got there. There's one image of, the shuttles pretty much nose to nose as they're both coming and leaving.
Oh.
There were a lot of iconic pictures there. It is definitely sad. I'm hoping that these being in museums so that people and kids can go and see this and maybe be inspired.
Yeah, maybe. I hope so. I hope you're right. Because, yeah, it's one of those things where I grew up with this space program and going into space and with the shuttles and all that kind of thing. So, yeah, I guess this, but we haven't had them for a longer period of time than we have had them. And it's just a new adjustment period, I guess. But great links in the show notes for this one.
Yeah, lots of images and lots of videos of it going here and there. And there was a whole bunch of people that kind of all put into a Flickr account. I believe it's like, hey, if you have a picture of the shuttle, send it in here.
See, that's what's great. Internet collaboration for the win on that kind of stuff. Yeah.
Yep.
Oh, there's the Flickr. Yeah, Heather's got the Flickr gallery linked in the show notes and all kinds of. Wow.
Yep.
Well,
all sorts of pretties for kind of a bittersweet moment there.
But something that is sort of looking towards the future is private deliveries to the space station. What's going on here?
Yes, we're coming up on the first very historic flight.
Yeah.
The first commercial transport to the International Space Station.
Next month?
Yes, it was going to be about 2 weeks earlier than that. Okay. Coming up fairly soon. But I think some issues came up and they wanted to be able to double check everything. So they pushed it back to around May 7th.
Is this the second pushback?
Yeah, a little bit. They've had a couple of delays, but...
Better safe than sorry.
Yeah, better safe than sorry. This is going to be the first, private industry delivery. So if they set this up and it's done right, then they can bring supplies up to the space station. So they can essentially, rent out this taxi service.
Ah.
So if NASA or the Russians need to get something up to the space station, then you call up the shuttle and, call up they're calling it the Dragon. You can call them up and be like, hey, we need a delivery.
Call up the Dragon.
Yes. Not quite pizza in 30 minutes or less, but it's another chance. So they want to do this right. They want to make sure that all their T's are crossed, all their I's are dotted.
Yeah.
NASA's going to say, you have to be this good. They're not going to be able to go up and actually dock with it. They'll come close.
And then just kind of throw it out the window?
No, they'll just kind of sit there, and then the space station will reach out, grab it with its little arm, and then pull it in. They're like, yeah, no docking quite yet, but you can sit next to us, and then we'll tow you closer in.
So, and then they'll dock them via the arm, or what? Okay.
And they'll pull it closer in so that they can.
So they're okay with NASA trained pilots and other nation trained pilots docking, but they just don't want the private guys docking.
Not yet.
Okay.
This is the first non-governmental thing, so I think they're kind of nervous. They want to make sure it's done right. Now, I definitely am pro doing this right, and if it takes a little bit of delays, even if it's delayed a month or two more, we're right there. It's about to happen. Let's make sure that this can continue, that it's not going to be in the news because, it's in the ocean or it's not in a happy place or it's in more than the pieces that it's supposed to be in. We'd rather it just be in the news because it's awesome and because it delivered supplies to the space station.
Yeah, absolutely. Yeah, not because it burned up. Yeah, I agree with you there. All right, Heather. Well, come on now. Come on, enough talking about the future. Jump into the SciByte time machine here with me. Come on, step in. Here we go. You ready?
Okay.
All right. Okay.
Yep, I'm here. Okay.
All right, every single week on SciByte, we take a look back into history to see what happened this week in science. And our destination this week takes us to April 25th, 1990, 22 years ago. What happened?
Yeah, we're not looking too far back into history this week, but the Hubble Space Telescope was actually deployed from the Space Shuttle Discovery, which we also talked about a little earlier.
Yeah.
So it was pretty much everybody knows about the Hubble Space Telescope. First major orbiting observatory, named in honor of American astronomer Edwin Powell Hubble.
Right.
Now, the poor thing was about 7 years behind schedule, quite a bit over budget, and then, had the primary mirror flaw that kind of sent back blurred images. Like, you got to wait for that first image. And you're like, awesome.
And it was bad.
No.
That's right.
Oh, no.
That was a big deal.
Yes. So then they were able to essentially send up a pair of glasses or contacts for the Hubble. They were kind of be able to correct for that in December of 93. And then they were able to get so much better images.
It's funny how much of that I remember.
Yeah. But
kind of sad. And now the Hubble has become invaluable, and I am really glad they stuck with it.
Yes. So it was 22 years ago that it was deployed.
Wow. How about that? There you go. So Hubble telescope, 22 years old. Well, a little older than that now, but 22 years in space. Not too bad. All right, well, let me recalibrate the SciByte computer here so that way we can look up into the sky. What's up in the sky this week, Heather?
All right. This week on Wednesday, April the 25th, you're going to see the constellation Orion to the lower left of the moon. This is one of the major constellations. I don't generally bring up the constellations, but it's one of the more iconic ones that's very easy to see. 3 bell stars all in a row. You can find it, images of it online. So it's kind of available to be able to see. It's going to be lower left of the moon on Wednesday.
Okay.
By the time you get to Saturday, April the 28th, there's going to be Mars and the star Regulus are going to be in the south. Saturn and Spica, another star, are going to be in the southeast, about 3 fingers apart if you hold it at arm's length. So there's going to kind of be some doubles. There's going to be Mars and Regulus, which, fairly bright, and then Saturn and Spica, which are also fairly bright in different locations.
Yeah. Okay.
And then as we kind of over the arch of days between Saturday, April the 28th, and as you get into, May 1st, you're going to see Venus high in the west just after sunset. It's going to be setting around 11 o'clock or so, U.S. time. And in general, this week, we're going to have Mars high in the sky at south, just about dusk.
Okay.
Jupiter is kind of low in the west, just at sunset. It's going to be way below Venus. But we still got it down in there in the west, so we can still see Jupiter for now. And Saturn's going to be low, kind of in the west, southeast. Oh my goodness. It's going to be peaking up in the sky about the highest point around midnight or so. And our friends in the southern hemisphere.
Yeah, which we have in the chat room tonight.
Yes, we do. Are speaking about Orion to the lower left of the moon. Of course, for them, it's going to be the upper left of the moon.
Okay. All right. Upper left of the moon. Got it.
Yep. So some of these they're all there. Sometimes it's just flipped in different, above to lower, left to right.
Right on. There you go.
Yeah.
Well, I always like looking up in the sky, so that way I can walk out when I'm taking out the garbage or I'm cleaning up the backyard. I can look up in the sky and go, I know what that is.
Yes.
And of course, you can too. If you forgot anything that Heather covered, you can go over to jupiterbroadcasting.com and you can find the show notes for episode 43 of SciByte. And in there, you can find links to everything Heather talked about, including what's going to be up in the sky this week. So
that's right.
Heather, I think that's everything we got for this week, yeah?
I think so.
Well, there you have it, everyone. That is this week's episode of SciByte. Now, SciByte is live over at jupiterbroadcasting.com/live, jblive.tv, on Tuesdays at 7:30 p.m. Pacific. And then we're out on Wednesdays for download. And you can get it in audio or video formats. Heather, thank you very much for a great show.
Thank you. Good show.
All right, everyone. Thanks so much for tuning to this week's episode of SciByte, and we'll see you next week.